Ever wonder what causes the wind to blow in different directions, at variable speeds around the globe? The answer lies in the concept of atmospheric circulation. This fascinating phenomenon is driven by the uneven distribution of atmospheric pressure across the globe. Air, like any fluid, flows from high-pressure areas to low-pressure ones. In simpler terms, air moves from areas where it is heavier to areas where it is lighter. Now, what causes this uneven distribution of pressure? The primary cause is the uneven heating of the Earth's surface. You see, our planet has a constant source of heat, the equatorial region, where the sun's rays are most direct, and two cold sources, the polar caps, where the sun's rays are least direct. This temperature difference sets up a grand global system of air currents, which we know as atmospheric circulation. And now you know the basics of atmospheric circulation, but let's delve a little deeper. Do you know how the cold polar air and the warm tropical air interact? It's all part of the fascinating dance that is our planet's atmospheric circulation. Let's break it down. Our atmosphere is divided into three main cells: the Hadley cell, the Ferrel cell, and the polar cell. In the Hadley cell, warm air rises at the equator and travels towards the poles, cooling and sinking as it goes. This movement creates the trade winds that sailors have relied on for centuries. The Ferrel cell, a bit more complex, is driven by the other two cells and creates the prevailing westerlies, winds that blow from the west. Finally, there's the polar cell. Here, cold air descends at the poles and moves towards the equator, creating the polar easterlies. And let's not forget the jet streams, high-altitude air currents that can influence weather patterns and aircraft routes. With this information, you can start to see how intricate our planet's weather system truly is. Does the wind behave the same everywhere on Earth? Well, not exactly. The Earth's rotation plays a significant role in the direction of the wind. This phenomenon is known as the Coriolis effect, which causes winds blowing from the south to the north to be deflected towards the west, and winds from the north to the south to be deflected towards the east. Now, let's talk about local winds. These are winds that occur in specific regions and are influenced by local geographical features. For instance, during the day, land heats up faster than water, causing air above the land to rise and create a breeze from the sea. This is known as a sea breeze. At night, the process is reversed, and we get a land breeze. Seasonal winds, like monsoons, are another interesting example. Monsoons are caused by the drastic difference in temperature between land and sea during different seasons. So the next time you feel a breeze, remember there's a whole science behind it, and that's a wrap on atmospheric circulation.